Take a moment to read the question. So we have been given a differential equation and the value of y when x is 0 is equal to 1. We have to find out the value of y when x is equal to pi by 2. How do we do this question? Well, the first step would be to divide the entire differential equation with 2 plus sine x. So we get this. Now we can rearrange it and write it down in this form. Now taking the third term to the right hand side, we can write down the equation in this form. Let's call this equation 1. Now this is clearly a differential equation of this type, which means it's a linear differential equation. Now from this we can identify our p function, and p is equal to cos x divided by 2 plus sine x. So we now have to find the integrating factor. So let us integrate p with respect to x, which means we are trying to integrate this expression. Now in this, the numerator is the derivative of the denominator. So this integral would simply be equal to log of the denominator. So the integrating factor can be found. It's equal to e to the power log of 2 plus sine x, which is equal to 2 plus sine x. Now we will multiply equation 1 with the integrating factor. So we get this on multiplication. The left hand side now is just the derivative of y times the integrating factor, and on the right hand side we have minus cos x. So we can integrate both sides and get this. The integral of cosine x is sine x, so we get this expression. Now using the initial conditions, we know that when x is 0, then y is equal to 1. So we can put these values and find that this is what we have. From this equation we can say that c is equal to 2. So we have found the constant. So putting the value of c back into the solution, we find that this is what we get. We need to find out the value of y when x is equal to pi by 2. So putting x equals pi by 2 and knowing that sine pi by 2 is equal to 1, we get this, which means y is equal to 1/3. So the correct answer is option 4.